Imagine a landscape sculpted by fire, a field of black lava rock stretching as far as the eye can see, or perhaps a vast plain of bare rock baked under the relentless sun, lifeless, silent, and still. A seemingly permanent testament to desolation. Yet return centuries later, after nature has had its way, and you might find a thriving forest, alive with the melodies of birdsong and the gentle rustling of leaves in a vibrant green canopy. This remarkable transformation is ecological succession. It's nature's patient, persistent way of reclaiming and reshaping barren landscapes, turning them into havens of life. Succession is a carefully orchestrated sequence of changes, a biological relay race, where one community of organisms, through its very existence, paves the way and prepares the ground for the next to flourish. The process begins with the arrival of tough pioneer species, the first colonizers. Microbes, lichens, and hardy plants. All are uniquely able to survive and even thrive in the harshest of conditions, where others cannot. These pioneers, through their life and eventual decay, slowly create soil and retain precious moisture, gradually making the environment more hospitable and suitable for a wider range of other species to take root. Over time, life's incredible persistence turns even the most desolate and seemingly inhospitable places into vibrant, thriving ecosystems teeming with life. Understanding the principles of succession is key to grasping how ecosystems recover from disturbances, both natural and human-caused, how they efficiently cycle nutrients, ensuring the continued health of the environment, and how they ultimately support the incredible biodiversity that makes our planet so rich and fascinating. It's a story that unfolds everywhere on Earth, from the tenacious plants pushing through cracks in city pavement to the vast regenerating forests that reclaim land after wildfires or deforestation. Succession is nature's enduring promise that from the simplest of beginnings, even in the most challenging environments, life, in its relentless drive, can create complexity, resilience, and breathtaking beauty. Primary succession starts with a blank canvas, bare rock, no soil, no life. Imagine a new volcanic island like Surtsey, Iceland, just rock and ash. The first arrivals, bacteria, algae, lichens, are carried by wind and water. Lichens break down rock, slowly forming the first thin layer of soil. As these pioneers die, their remains mix with rock particles, creating primitive soil. This allows hardy plants like mosses and ferns to take root, further enriching the soil. Each wave of new species makes the environment more hospitable for the next. Over centuries, grasses give way to shrubs, then to fast-growing trees. Each stage adds nutrients and structure, setting the stage for a young forest. From bare rock to woodland, primary succession is a slow, patient transformation. It's a testament to life's ability to build something from nothing. Secondary succession is nature's recovery act, a testament to the Earth's incredible ability to heal. It's a process where life reclaims a space, not from bare rock, but from a place where life once thrived. Life returns where an ecosystem was disturbed, but the crucial element, the soil, remains intact. This could be after a fire, a flood, or even human activities like logging or farming. Picture an abandoned field, a blank canvas ready for nature to paint upon. The soil is intact, teeming with life. Seeds lie dormant, waiting for the right conditions to sprout, and microbes are ready to kickstart the nutrient cycle. Fast-growing weeds and grasses appear first, opportunistic pioneers that quickly colonize the open space. They play a vital role, stabilizing the soil with their roots and adding precious organic matter as they decompose. Soon, perennial plants and shrubs take over, establishing themselves as more permanent residents. This is followed by sun-loving trees like pines or aspens, the pioneer tree species that can tolerate harsh conditions. These new arrivals create shade, gradually transforming the environment below. This changing environment alters the conditions and allowing shade-tolerant trees to grow, species that couldn't survive in the full sun. Over decades, hardwoods like oaks and maples slowly replace the pioneers, a testament to the constant competition and adaptation within the ecosystem. Eventually, this leads to the formation of a mature forest, a complex and interconnected web of life. This entire process is much faster than primary succession, which starts from bare rock. It can take sometimes just a couple of centuries, a blink of an eye in ecological time. The key is the legacy of the soil, the foundation upon which this recovery is built. This speeds up recovery and supports a rapid return of biodiversity, as animals and other organisms find their way back to the regenerating habitat. Secondary succession beautifully shows how resilient ecosystems can be after disturbance, highlighting nature's remarkable capacity for renewal. It's a dynamic process, a constant dance of change and adaptation, with each stage building on the last, creating a more complex and stable ecosystem over time. From weeds to woods, a transformation that showcases the power of ecological succession. Nature's second chance is swift and remarkable, a powerful reminder of the enduring strength of life. Succession isn't random, it's a carefully orchestrated process. It's a dance of species, each playing a role in transforming the environment. It's shaped by three main mechanisms. These are the driving forces behind ecological change: facilitation, tolerance, and inhibition. These three concepts dictate how species interact and how ecosystems evolve over time. Facilitation: early species like lichens, the first colonizers on bare rock, or alders, hardy trees that can thrive in poor soil, improve conditions for later arrivals, paving the way for more complex life. By creating soil or adding nutrients, enriching the environment for future generations of plants and animals. Tolerance: some species, like oaks, simply endure the conditions created by pioneers. They are patient and resilient, and eventually outcompete them, slowly but surely taking over the ecosystem. Inhibition: early species can hinder newcomers, for example, by shading the ground, preventing sunlight from reaching seedlings, or releasing chemicals that prevent other plants from growing. This is nature's way of controlling the pace of change. Succession advances as disturbances, or the death of dominant species, open space for new arrivals. These gaps in the ecosystem create opportunities for new life to flourish. These mechanisms interact, driving the ecosystem from simple beginnings to greater complexity. It's a story of constant adaptation and change. Facilitation helps new species establish, tolerance allows some to persist, and inhibition slows others down. It's a delicate balance that shapes the future of the ecosystem. The balance between these forces shapes the pace and direction of succession. It determines whether an ecosystem will remain stable or continue to evolve. Understanding these interactions explains why ecosystems change the way they do. It gives us insight into the intricate workings of nature. It's the engine behind nature's constant renewal, a testament to the resilience and adaptability of life on Earth. As succession unfolds, ecosystems transform in predictable ways. Soil deepens and becomes richer as generations of plants and animals add organic matter. Biodiversity rises. Simple pioneer communities give way to complex forests with many niches. Vertical layers, forest floor, understory, canopy, support diverse life. Biomass increases dramatically, with mature forests storing vast amounts of carbon and energy. Food webs become intricate, with more species and connections. Decomposers like fungi and bacteria recycle nutrients, making the system efficient. Nutrient cycles tighten, and energy flows through more complex pathways. Each stage builds on the last, assembling a living world piece by piece. Observing these changes reveals the power and order of ecological succession. It's nature's blueprint for building thriving ecosystems. Ecologists once believed succession led to a single stable climax community, like a mature maple beech forest. This climax was seen as the endpoint: stable, self-perpetuating, and unchanging unless disturbed. But modern ecology sees things differently. True, permanent climax communities are rare. Most ecosystems are dynamic mosaics, with patches at different successional stages. Small disturbances, like tree falls or fires, constantly create openings for new species. This shifting mosaic maintains higher biodiversity than a static climax ever could. Even in mature forests, mini succession cycles are always underway. The climax concept is still useful for exams, but real ecosystems are always in flux. Stability is relative, change is constant. Succession is less a finish line, more a never-ending process of renewal. Succession isn't just theory, it's vital for exams and conservation. Know your examples? Glacier Bay, Alaska, for primary succession, abandoned fields for secondary. Remember, primary starts with bare rock, secondary with soil. Pioneer species like lichens and mosses start the process. Climax species like oaks and maples finish it. Key mechanisms: facilitation, tolerance, inhibition. During succession, soil depth, biomass diversity, and food web complexity all increase. In conservation, understanding succession helps restore damaged lands by planting pioneers, stabilizing soil, and guiding recovery. Nature heals, but rebuilding complexity takes time. Succession teaches resilience and the value of protecting mature ecosystems before they're lost. It's a lesson in patience, hope, and the enduring power of life.